we have to find the dimension of universal gas constant. Number 1, from the ideal gas equation, PV equal nRT, where R equal to 8.31 joule per Kelvin per mole. So this is what universal gas constant. This is the value of universal gas constant. Gas constant. P is the pressure, V is the volume of the ideal gas, T is the absolute temperature of the gas, and N is the amount of substantial number of moles. Hence, what we can say, dimension of R, dimension of universal gas constant will be equal to dimension of pressure into volume divided by dimension of amount of substance into dimension of absolute temperatures. Absolute temperature, and dimension of PV is equivalent to dimension of work done. Since what dimension of W is the product of dimension of pressure and volume. And what about W? W is work done divided by dimension of N into dimension of T. So now dimension of work done is, we know that M L square T to the power minus 2. Dimension of N means mole and dimension of T means absolute temperature, which is Kelvin. So finally we get the dimension of universal gas constant as M L square T to the power minus 2 Kelvin inverse and mole inverse. This is the dimension of universal gas constant. Universal gas constant. This is the dimensions of universal gas constant. Now, next topic is what? Avogadro's number. The value of Avogadro's number, Na, is 6.023, which is very large number, into 10 to the power 23, plus 23, and unit is mole inverse. Hence, dimension of Avogadro's number is what? Mole inverse. Mole inverse. What is the dimension of Boltzmann constant? We know that Boltzmann constant K is the ratio of universal gas constant and Avogadro's number. And if we put the value, then we get the value of Boltzmann constant as, what is the value of R? 8.31, and Na is 6.023 into 10 to the power 23. Hence the value of Boltzmann constant is what? If we divide, then it should be 1.38 into 10 to the power minus 23 joule per Kelvin only. This is the value of Boltzmann constant, and we have to memorize this value also. Now, therefore, dimension of Boltzmann constant is equal to dimension of universal gas constant divided by dimension of Avogadro's number. Now we know that dimension of universal gas constant is ml square T to the power minus 2 Kelvin inverse mole inverse, and Avogadro's number has the dimension mole inverse. So finally we get the dimension of Boltzmann constant as M L square T to the power minus 2 Kelvin inverse. Now, next quantity we have to know what should be the dimension of Planck's constant. Dimension of Planck's constant. We can erase this part. Number 4, Planck's constant. We know that the energy of photon is given by E, which is h nu, where what is nu? Nu is the frequency. Nu is the frequency of the photon or light energy. And h is the Planck's constant. And here, what is h? The value of h is 6.62 into 10 to the power minus 34. 6.626 into 10 to the power minus 34 Joule second. So this is what Planck's constant. This is Planck's constant, the value of Planck's constant, which is related to the energy of photon. Packets of energy is called photon. This is the value of Planck's constant. Now, therefore, what is the dimension of Planck's constant h? Dimension of energy divided by dimension of frequency from this equation. So, dimension of energy is what? M L square T to the power minus 2. And dimension of frequency is T inverse. So, finally, we get the dimension of Planck's constant as M L square T to the power minus 1.